Hello, and welcome to FalconEditor, Duality's new tool for visually creating digital twins and simulations. FalconEditor was developed by extending Epic Games' Unreal Editor, the popular tool used by major game studios, and making it equally accessible for digital twin simulation workflows. In addition to all the standard Unreal Editor capabilities, with FalconEditor you can convert any available 3D asset to simulation-ready digital twins, import, create, and customize digital twins of environments, items, and systems, visually author any real-world scenario, simulate and troubleshoot that scenario and generate synthetic data, and export digital twins and scenarios for Falcon Cloud to be shared with your team, collaborators, or external stakeholders. Let's start with creating digital twins from available 3D assets. As with standard Unreal Editor, we can bring 3D assets into FalconEditor from DCC apps and then convert them into Unreal assets, also known as U-assets. To make this U-asset simulation ready, we'll need to promote it to a digital twin. A digital twin carries additional properties and layers of information vital for simulation, and we configure some of this information in the digital twin dialog. The new digital twin is given a name and a brief description. The twin type is auto-recognized and assigned by FalconEditor. Actor blueprints become item twins, while pawn blueprints become system twins, and levels are automatically recognized as environment twins. In this dialog, we can also add Python scripts that define digital twin behaviors and functions. Promoting the 3D asset converts it to a digital twin defined by the USD-based Digital Twin Encapsulation Standard, or DTES, an open standard developed at Duality. The standard is designed for maximizing interoperability and allowing for reusing the twin in any context. Once promotion to a digital twin is complete, a new twin directory is created that contains the twin's USD and Python scripts. A source folder is also created, and it contains all assets that will be referenced by the USD when working in the scenario creation mode of FalconEditor. Creating scenarios. Next, we're ready to use digital twins to create a new scenario. A scenario first needs an environment, and we can use any environment from the Digital Twin content browser. In this example, we will do this by simply selecting the Sedona Desert twin and dragging and dropping it into the viewport. Next, we'll introduce our first system twin, a quadcopter. Just as with the environment, we select it from the content browser and drop it into the viewport. Using the outliner in the top right corner, we can see the evolving hierarchy of the scenario we are creating. All digital twins and their components show up in the outliner once we add them to the scenario. Now we center our attention on the quadcopter in the viewport. We can move the quadcopter around using the XYZ arrows, exactly as we would an asset in the Unreal Edit mode. When we position the digital twin, that dictates its starting location in the scenario. As we did with the environment and system twins, we'll now add an item twin, a wind turbine. The addition of the twin is instantly reflected in the outliner, and we can move the turbine to any desired location. Adding sensors. We can add a sensor to any system twin by right-clicking on it and selecting Scripted Actor Actions. Next, we select the sensor type. In this case, we'll be using the capture sensor, and once loaded, we can position the sensor exactly the same way as positioning a twin. The sensor will always maintain its position and orientation relative to its parent. When the sensor is selected in the viewport, we can also see it displayed as a child of the system twin in the outliner, and we can customize various attributes in the Details panel below. This includes setting up the writing of the data to disk, changing sensor settings and orientation, selecting the types of data to be recorded, and much more. Since we've already equipped the capture sensor, we can now choose from a variety of data types to record simultaneously. For this example, we select an RGB camera channel. Running the simulation. With the desired system twin selected, we can now launch Falcon Sim directly in the FalconEditor viewport. Being able to run the Falcon Sim directly in FalconEditor allows us to test and troubleshoot any scenario all in one place. Once the scenario has loaded and the simulation begins, we can fly the quadcopter around the Sedona Desert and collect perceptual data for our camera sensor. The generated data is written to disk as soon as it's captured. We can review all the images in the directory specified in the sensor settings. This is an important step in confirming that the sensor is correctly set up and that the data being generated is aligned with our needs. Exporting to Falcon Cloud. Once the scenario or digital twin is ready, it can immediately be utilized locally in Falcon Sim or uploaded to Falcon Cloud where it can be shared with all permitted team members and collaborators. With Falcon Cloud's intuitive interface, they can either download digital twins and scenarios directly to their local system, or simulate in Falcon Cloud with zero hardware requirements. Hopefully this high-level overview has given you an idea of what FalconEditor can do, and how it streamlines any digital twin simulation workflow. For any questions, please contact your Duality representative.